What if we told you that your favorite transition metals had a social life? Interesting, isn't it? They do in the world of chemistry through a fascinating concept known as coordination compounds. Coordination compounds are like the social gatherings of the atomic world. At the heart of these gatherings are transition metals acting as Lewis acids, which bond with ligands or Lewis bases. These complex ions then associate with counterions, ions of opposite charge, forming neutral compounds. Imagine a grand ballroom dance with the transition metal being the ballroom itself and the ligands being the guests. The counterions are like the event organizers, associating electrostatically, not covalently, with the complex ion. They are placed outside the brackets in a formula, while the ligands, bonding covalently to the transition metals, are part of the primary coordination sphere and placed inside the brackets. The coordination number, akin to the guest list at our imagined party, is the number of atoms that are bonded directly to the metal. The counterions, on the other hand, are part of the secondary coordination sphere. This sphere might also include ions that associate electrostatically with the complex or neutral molecules that interact with the complex via intermolecular forces. Let's delve deeper into the bonding in these compounds. Complexes form when metals and metal ions act as gracious hosts, or Lewis acids, accepting electron density from the guest ligands, the Lewis bases. This bonding is known as coordinate covalent bonds or dative bonds, where one atom donates all the shared electrons. Ligands, like any good guest, come bearing gifts. In this case, at least one lone pair of electrons that is available for bonding. The atoms within a ligand that donate a lone pair are called donor atoms. Now, not all ligands are alike. Some, like NH3, can form only one bond to a metal, whereas others have multiple donor atoms with lone pair electrons that can bond to the metal. Ligands that can form only one bond with a metal atom are known as monodentate, one tooth. And ligands that can form more than one bond to a metal are known as polydentate. The coordination compounds also have geometrical structures. For example, compounds with coordination numbers of 2 have linear geometries, whereas those with 4 have 2 possible geometries. Metal atoms or ions with d10 electron configurations tend to form 4-coordinate complexes that are tetrahedral, while those with d8 electron configurations form square planar complexes. Most 6-coordinate complexes have octahedral geometries. In summary, coordination compounds are fascinating structures where transition metals bond with ligands and associate with counterions to form complex ions. These compounds exhibit a range of geometries depending on their coordination numbers. They truly bring to life the social interplay of atoms in the microscopic world of chemistry.